Okay, hi everybody. Welcome to the lab, or the listening room, I guess. Got kind of a short hangout for you this week. I'm working on some other things that are taking up some time, but I did want to share a couple things with you. So let's go right to the slides. Let's back up. There we go. That is a 2SK180 opened up, and you can see that it has a really big chip. That's actually a 1 centimeter chip, so it has more than 3 times the surface area of the Sony 2SK82 that we've been working with, and so it can dissipate more heat, and it has higher capacitance. And that's what it looks like inside. And then this monster is that is the 2SK182ES. That's a 1.5 centimeter chip, and it has these heavy red wires. Those are actually the gate terminals, and this silver electrode on the top, that's the source. And I mean, just look at this thing. It's built like a tank. It's a 500 watt part, and so that's what it looks like. And these are bad parts, by the way. I didn't dismantle good parts. All right. Here it is. This is the 2SK182ES. This is a good part. This is what a good part looks like. And you might recall I had some of these, and I just wasn't happy with the way they looked, and I thought they might be bad, but I had 2 that were identical, and so I thought, well, I don't know, maybe that's just what they look like, and but no, this is actually this is what a good part looks like, and it's a nice part. You can see it has a little more move than the 180, and a little lower drain resistance. And yeah, so good part. It also reminds me of it reminds me a lot of the Pass-Sit 1 in the range of maybe 0 to 40 volts or so. And they look different outside of that, but from say 0 to 40 volts, there's definitely a certain resemblance. And then this is the same part at a different scale. So thanks, Paul, for trusting me with your parts, and we appreciate that. This is this is one of my bad 2SK182s, and it wasn't the uneven spacing as much as the this drain resistance thing going on here, and I thought, well, maybe out here at higher voltage it starts to straighten up, but it really doesn't. It just never gets better. And I tried to get these parts to do something. I wired him into an amp, and I don't think I ever got better than maybe 1% THD at a watt or something like that. So there it is. They're just bad. And I don't know if this is just bad quality control, or if this is what happens when they fail in the field. But I did find this is a bad 2SK180, and you can see it has that same kind of thing going on. And so maybe this must just be some sort of a failure mode for these parts. So there you go. Okay, Paul let me wire one of his parts up into an amp so I could check a couple things, and so I did that, and let's check that out now. All right, I'm in the lab here, and I have wired one of Paul's 2SK182 ES into common source amp, and I'm just making some observations about the input capacitance and the gate leakage current. And if you take a look at the temperature meter there, the case is at about 63C right now, and I have been measuring the gate leakage current versus temperature to get an idea of the temperature dependence of that figure. And if you take a look at my board, you can see we started out at 33C, and we were dropping about 140 millivolts across the 10K capacitor, and that crept up until we got to 59 or 60 degrees or so, and then things kind of settled in, and after about an hour we were at 62C and 273 millivolts, and right now we're at about the 2-hour mark, I think, and we're at 64, and we're at 195, I believe. We're about 200 millivolts right now, so that's what that looks like. No big deal. It just means let your amp warm up and adjust it after an hour or two, and it has been behaving itself pretty well. The circuit I've settled on for the moment is the voltage across the device is about 24 volts, 23.5, 24 volts. And this is a 50 volt supply, and we're idling at about 2.25 amps. And this is doing about 0.3% THD at a watt, and it's working really well. These are nice devices. It's got a lot of gain. This amp has about 15 dB of gain, and it also has a lot of input capacitance, and we'll talk about that, but you may need to address that. You're going to need a preamp with a really low output impedance, or maybe a buffer, or maybe we'll wire a buffer into this circuit. So there we go. Okay, so I just wanted to point out that that temperature there that's the case temperature, not necessarily the heat sink temperature, because the heat transfer is imperfect, and it's certainly not the chip temperature, which ideally we would measure the chip temperature, but we have no way of measuring that directly. So we measure the case, and the case and the heat sink and so on, these different materials heat up at different rates and things like that, and so it takes a while for things to balance out. But you can see we ended up at about 0.2 volts over 10,000 k ohms, which gives us 20 microamps of gate leakage current there. So, and I think that was at about 22 volts drain to source, something like that. And that's fine. That's perfectly manageable. The Sony parts that I've been using, I've never seen more than 1 or 2 microamps, but we can deal with 20, and that's well within spec. I think the spec is 100 microamps max. So there you go. Capacitance, yes. In order to determine what the effective input capacitance is, I wired this into the common source circuit, and which is you really should build some of those prototyping stations. A couple of light bulbs, a chunk of plywood, and some input and output terminals, and because it's a great way to test things, and you can test more than just DC conditions and things like that. And you can test more than just SITs, of course. I mean, you can wire other kinds of devices into that circuit and see what they do. Anyway, I use that to test the effective input capacitance, and the way that we do that is we find out at what frequency we reach minus 3 dB, and in this particular case, that happened around 18 kilohertz. And if I use my handy chart here, I can see that at 18 kilohertz, I'm at about 2, 4, 6, 8, 10, 12, 14. I'm at about 14, and yes, that's 14,000 picofarads. Now that's a lot, but we can deal with it if we know about it. And to give you an idea, you may be thinking, well, my data sheet says it's 3,000 puff or something like that. But you remember that the effective input capacitance is amplified by the Miller effect, and so we end up with a pretty big number. It's 1 over 2 pi. Times the source resistance times the cutoff frequency. And the Miller effect amplifies the intrinsic input capacitance by the voltage gain. So this, I mentioned, this part has more gain, and that increases the effective input capacitance, and this is the actual capacitance that you will experience using this in a common source circuit with no feedback. And so if your preamp has a 1K or 2K output impedance, look out. You're not going to hear many high frequencies. But on the other hand, if your preamp has a 50 ohm output impedance, or your buffer, then you'll get minus 0.2 dB at 20 kilohertz and about minus 2 at 80 kilohertz. So you can deal with this. You just have to have a low source impedance. And here, this is my Adjusto Load 5000. I was just messing around with that yesterday. I got a bunch of sockets and bulbs and rheostat there, and I can use that to configure these bulbs in different series and parallel combinations and make little adjustments. And we'll talk about what I did with that a little further down the road. Okay, so what's coming up? Well, I'm working on a load line tutorial video, and that has been really the most popular request has been do something on load lines and what they are and how to draw them and make them and what can we use them for and can they help us find the sweet spot and all of that kind of stuff. So I'm working on a video dedicated to that topic, and I should have that ready pretty soon. And we'll continue to work on Sound Happy's amp. He has some 2SK182 ESs, and we'll work on a little amp design for him. And probably start out with something lower voltage, and then maybe later on we'll work on something that exploits the high power capability of that part. And then I've got some more top secret stuff we can talk about, and then lastly, you tell me what you'd like to see, and post something in the YouTube comments here, and let me know, and I'll see what I can do. Okay, I have some shout outs to Dirk1. I noticed that Dirk1 is just finishing up a pair of Hammond 193V lamps, and so I hope that's going well for you, and good luck with your project. Christophe, comment allez-vous? Esteban, how are you, sir? And of course, Gerd, wie geht's dir? I hope that sounded a little bit German. Thanks, everybody. That's all for this time. Remember, there aren't many of us in this hobby, and there are even fewer of us interested in this very narrow niche of really super simple amps and static induction transistors and stuff like that. So please subscribe and post your comments and spread the word so that I know if this is useful and worthwhile. Thanks for hanging out with me, and I will see you next time.